Good morning. So, we will continue about the design of clutch system. I think so far we have discussed the clutch types, clutching working method. Particularly we discussed about the torque transmitting capacity with respect to for single plate clutch. Within that we have discussed about uniform pressure theory aspect as well as uniform wear theory. Now we will move on to the other type of disk for torque transmitting capacity aspect. So we are going to learn about multi-disk clutches aspect and also cone clutches, and we will do a couple of problems from today's lecture. Right, okay. The question is, we have discussed about the single plate clutch system, right, and we have seen the model also, very big size, right, okay. But the problem is the size is big, and also when considering the surface area, the actual surface area, do you think this is enough to transmit the higher torque? That is the question, right. So, if we want to transfer the more torque, we need to have the more surfaces, that is one aspect. So, not only that, you need to transfer the more torque, but maybe if you reduce the space limit, if there is a space limit, then we need to have again a different aspects, okay. So, what I want to say that when you want to have a large torque capacity transfer, that is one thing, large torque capacity aspect, and also you have to have more surfaces to have a high heat capacity, okay. In that case you can't use a single disc clutch. Not only that, the wear, okay. Remember I asked one question, there are two discs rotating, they contact each other through spring mechanism, a diaphragm, then the power is transferred from the drive to driven, this is what I said, through friction lining, this is what I said. But I asked you one question, the clutches are operated in oil condition also, right, remember this is the question I asked you, why, right, okay. So, if we have a dry clutch, the wear will be very high. The moment you have lubricated, the wear will be reduced. So, what I want to say that when you want to have a multi-disc clutch system, you have to look at different aspect in terms of higher torque capacity, high heat transfer, low wear, more importantly high power weight ratio, so that as smaller the size you can transfer the higher power, and especially the space restriction, right. So, the clutch size is probably maybe 12 inches, that is the diameter, right. So, single plate, whereas for scooters and motorcycles or motorbikes, do you think that is good enough? It is too big, right. Of course, we are doing a projects for two different aspect, one is a jeep, other one is sports vehicle, right. So, when you have sports vehicle, the space is even more limited. So, what is the solution then? So, in that case, when you have a high torque, high heat capacity, and you need to have low wear at the same time, as small as possible, then the only solution would be multi-disc clutches, okay, multi-disc clutches. So, this is the arrangement, you can see that, okay, very interestingly. This is the complete assembly, you can see this is the complete assembly, and this is the if you do the cross section, only half of the cross section, you can see that. So, when you cut through here and zoom in, right, so you would see in this arrangement, okay. Look at this, you have two things, one is the backup plate, I will explain what does that mean. This is your backup plate, then you have a separate plate in between friction discs also there. The separate plate is called as a rotor, the separate plate called as a rotor, the friction disc is called as a stator. Hope you do remember what do you mean by rotor and stator, one is rotating, other one is fixed. And if you look at the arrangement, okay, what is this? This is nothing but your friction thing, right. So this one and here this one, they are arranged to one link. They are arranged to one link, whereas this one you can look at again very carefully. The rotors are arranged in another link. So what happened through the spring, when you do the operation, they will press against each other. Okay, they press against each other. You can see that. So normally the rotor will be more than your stators or friction plates. Okay, let me ask one more question. Have you ever seen aircraft brake system? Aircraft carrying very heavy energy, right? Okay. So during the landing, they had to not only apply the thrust where flaps will be open. Okay, flaps will be open. That will reduce the things. That won't be enough. That won't be enough, and you need to have a brakes also. So what type of brakes do you expect? I'm sure in the thermal analysis we would have seen that, right? So what type of I just wanted to say that what type of disc brakes are available, how many disc brakes are available in the aircraft, not the clutch. Have you seen, did I show any pictures of that? It's a multi-disc, okay. In fact, the temperature will be more than 200 degrees Celsius. Usually they go for a carbon composite brake aspect. Same concept, same thing is applicable for a multi-disc clutch system. The operation is similar, right? That's the thing. So you could see that. So you have a stator and a rotor, then arranged in a staggered manner based on the capacity, how much torque you want to transfer, and do the performance. Okay. So otherwise, this is same as a single plate clutch system. Only difference is you will have a more number of surfaces. Yeah. So this is taken from Liang Yu from tribalism transaction. And advantages, they increase the amount of torque able to transmit it, you decrease the pedal operate to clutch, and obviously you are reducing the size also, right? So even though you are creating the number of plates or number of discs more, but the overall weight you are reducing. The moment you are reducing overall weight, what happened? Your specific fuel consumption will be improved. Okay. And one more thing is, the inertia effect also can be reduced. Obviously, a larger diameter, the inertial effect will be larger, right. So the moment you reduce the diameter, the inertial effect also can be reduced. So that is the advantage, that is one of the advantage having a multi-disc clutch system. So this multi-disc clutch system is used in all two-wheelers, be it a scooter or a bike, motorbike, right, or even heavy sports vehicles. They use this type of multi-disc clutches. So the same equation, only difference is you have to multiply number of surfaces. That's what is given. Z is given from uniform pressure theory. For uniform wear theory, you can see that there is a equation should come. Yeah, the same equation, mu p z, right. So this is your RF. Similarly, mu p z, and this is your RF for the uniform wear theory. Z is the number of pair of contacting surfaces. Okay. So number of pair of contact surfaces within that. So suppose if I want to have a 3 friction plates, so how many I need to have rotors? Assuming I have 3 stators. So rotor, stator, and should end with the rotor, not the stator. So obviously the number of surfaces would be, right, Z plus 1, number of discs. Okay. So number of disc will be Z plus 1. So the Z1 is the number of discs on the driving shaft, which nothing but your rotor. Okay. And Z2 is the number of discs on the driven shaft, which is nothing but your stator. Okay. Let me ask one more question. Have you ever observed how aircraft is landing on the ship. I am talking about ship carrier. Have you ever seen it? Ship carrier, warship maybe, right? What would be the typical what is the typical runway? The runway is restricted to 800 to 100,000 meters, 800 to 1000 meter, whereas on the airport, the regular surface airport, you will have large runway. So, but the fighter aircraft will come very high speed, not the regular speed of your passenger or flights or cargo flights. So, what happened? How do they achieve? You have thread is there, that is one thing, it is called arrested barrier, okay. Arrested barrier, but you will see only thread, but underneath the deck there is a brake system, which is arrested barrier brake system, which exactly will have the rotor and stator, very huge, okay. That is also there. And this is the you can see that the same equation, if you I mean compare to your single plate, I will remodify, it is a mu, which is a mu p, right, and Rf is the friction radius, right. Only thing is you have to multiply the number of contact surfaces. Similar way, it's the same equation, mu p and Rf z will be, need to do that. So, this is multi-disc clutches. Normally, the moment you go for multi-disc, by default they are lubricated. That is the difference, understand that, okay. This is why I asked you in the previous lecture why you need to have a lubricated, because the surfaces are more. When the surfaces are more, the heat generation more. When the heat generation more, right, the wear will be more. So, to avoid that, they will entire the clutch system, multi-base system will be immersed into lubrication in the things. This is the reason precisely I asked you a contradicting question. Our purpose of clutch is to have a friction, then what is the need of lubrication, right? That was the question I asked you. Now you know the answer. So, the reason is you need to have friction, at the same time you have to look at other performances also, right. When you look at, right, based on that the lubricant need to be provided for the multi-disc clutch systems. Now you can see the difference between the dry and wet clutches. For single plate clutch has a higher coefficient of friction, usually very high, greater than 0.3, you can see that. However, if you look at the multi clutch, right, they have a less than 0.1 because they are lubricated, that is a difference, okay. The torque capacity of dry clutch is high compared with the wet clutch of the same given dimensions, right. Obviously, the lubricant will reduce the friction aspect, okay. The heat dissipation is difficult to dry clutches. In wet clutches, the lubricant oil arrives away the frictional heat or carries away, should be carries away, spelling mistake, the carries away, because the purpose of lubricant is develop a film between the two surfaces and remove the heat as a coolant, okay. So, that is another reason. The wear rate is far less in wet clutches compared with the dry clutch, obviously it has the lubrication, right. Yeah, the engagement in wet clutch is smoother compared to dry clutch, holding them difficult, right, whereas you have very good compartment having a place rotor, stator and backup rotor also, they are all linked. So, well synchronized mechanism is available for multi disc clutch system. That is the thing, okay. Now, we will move on to the cone clutch, okay, the cone clutch. There is a one more type called as a cone clutch. Have you ever seen the cone clutch first of all? If you had come to my office, I would have shown some synchro mesh gears, I would have shown that, right. Maybe I forgot to bring it here, but I will show it maybe tomorrow lecture. So, the extensively used for transmission aspect, okay, that is one specific application of cone clutch. Any application do you aware of for cone clutch aspect? How about moped? In Moped they have a cone clutch arrangement. Okay. So what is the difference? What is the need of cone clutch, right? Because this is the typical arrangement of cone clutch, right? This is the arrangement. So let me finish these things. So you have a female cone. This type is a drive. This is coming from the engine. This is the drive, and this is your driven thing. Okay, this is the driven side, and this is the female cone, and this is the male cone, or part or counterpart like this. And this is the where you have a friction lining. So you can see that this is your friction lining. This entire portion is your friction lining, and of course you have a spline also, where that this is actually fixed with the flywheel. This part is fixed with the flywheel, right, and this part is extended to the gearbox. Yeah, that's arrangement. And you have a spring actuator to make a proper clamping, right, clamping aspect. So what excuse me. So what is your observation? How does this different from regular plate clutch? That's a question. Look at this. You have a nice cone arrangement. Will give you a more real contact surface. Real contact surface. Right. Real contact frictional surface. So that's the advantage. Okay. Let me ask one more question. The basic question. You have rotating disc, this one and this one. Okay. This when the press due to clamping force and try to attain the same speed, right? There is a possibility of slip. There is a possibility of slip. But if you have cone arrangement, then another counterpart, right? Like that's what I said. So when they move together, right? Do you expect any possibility of slip? Very less or limited. Okay, that's the advantage. Not only advantage, first they will make contact. First they will make contact, then they will attain the speed. That's how they do that. So that means making a proper contact through the wedge action. This is nothing but wedge. If you look at, probably you see the better aspect here. Yeah, you can see this is in fact. So the arrangement will happen between these two. So this is nothing but wedge shape. Okay, this is wedge shape. So then the end. This is alpha is nothing but your cone angle. Maybe I'll say that. Okay, alpha is nothing but semi cone angle. Semi cone angle. So you have to the same concept similar to single plate clutch. Only difference is you will have a wedge shape, right? So that means the normal force will act along this the friction lining. Usually we take it as this is the face width B. B is the face width, similar to your gear face width, right? B is the friction face width. Yeah. Of friction lining. Okay. So if you rearrange, right, if you rearrange, maybe I can show you a better way. The forces. Yeah. The only difference is, yeah, straight away I am giving you the thing. Yes, from the strip, right? So if you see the strip, I am taking only the half of the thing. So this is your R, right? This is your R, and this should be your D. Maybe I'll say capital R, small r, a small d by d, like this. Yeah, this is capital D by d. And this is your alpha pressure angle. So this will act in this direction normal way. So then you will have a two components, vertical component and the horizontal component. This is your activation force P, right, with the smallest period P delta, okay, and this should be a cos alpha and this should be a sin alpha. So if you do that, the sin alpha will come into denominator. That's the difference is coming. So rest of the thing same, right? Only this is the thing, okay. So normally the semicone angle is recommended 12.5, right. So let me explain one more concept. The cone should be lesser than the certain angle, okay. Assuming this is a slope, you have a slope, right. I have a block, right. When we expect the block will slide, assuming this is the load is W. When do you expect the block will slide at what angle? At what angle? Tan, sorry? Yes, or mu equal to tan theta, right? Mu equal to tan theta. That means, okay, so if the moment you increase that the theta should be, right, that is your angle of repose. It's called angle of repose, okay. This theta, what are you do, right? So we have to maintain alpha always lesser than the theta. Alpha is lesser than the theta, and one more thing is the friction should be lesser than static coefficient of friction. Obviously, this is the condition. This is the reason, two condition, okay, to avoid the slip, right. So question is, what happen if you keep the angle equivalent to theta, your semicone angle? What do you expect? Do you expect there is a contact? Do you expect there is a frictional contact such a way to transfer the power from female cone to male cone? No. So they will have kind of self locking. You expect self locking because it will slide, you cannot make it. So this is the particular reason you have to keep your semicone angle as low as possible. Perhaps when I show the synchro mesh gear, I will show what is the angle. You can see that very small, probably 3 degree or 4 degree, as low as possible, okay. So this is a transconducting capacity for a clone catch aspect, okay. And we will do a problem, please, okay. We will do two problems now. Can you take down the problem number 2, please? A small problem. So problem number 2, question number 2. An oil immersed multi-disc clutch with the molded asbestos on one side and steel disc on the other side is used in application. The torque transmitted by the clutch is 75 Newton meter. The coefficient of friction between the asbestos lining and the steel plate in the wet condition is 0.1. The permissible intensity of pressure on the asbestos lining is given as a 500 kilopascal. The outer diameter of the frictional lining is kept as 100 mm due to space limitation. Assuming uniform wear theory, calculate inside diameter of the disc, the required number of discs and the clamping force P. The clamping force P you need to find, okay. The required number of, you need to find out inside diameter of the disc, the required number of discs as well as the clamping force. This is the problem, yeah, very simple problem. So if you look at, this is your torque T m or T, this is your mu, right, and this is a maximum allowable pressure 500 kilopascal, right. Capital D is given 100 millimeter, yeah, clearly given. Data given data, torque 75 Newton meter, okay, fine. Mu equal to 0.1 and PA 500 into 10 power 3 Pascal, or else we can say that straight away 0.5 Newton millimeter square. That's one thing is given, and D is given how much? 100 millimeter. This is clearly given. Okay. It asks you to use the uniform wear theory, right? Uniform wear theory. Uniform wear theory, T equal to mu into P by 4. This is your general equation, right? And you need to multiply Z. You have to multiply Z. Okay. So torque is given. Yeah, torque is given. Okay, torque is given. What else we know? We know torque is known to us. Mu is known to us. P we don't know. And we know only D, and this is not known, and this is also unknown. There are so many unknowns are there. So many unknowns. How are you going to solve the problem? Okay. When do you expect the maximum torque will be transferred during when you have a clutch system? When do you expect maximum torque? Remember, I said one information, better to keep D by D ratio 1.5 to 2, right? In this condition, in fact, I gave clearly 1.7. I think 1.7 is the at maximum torque will be given. Okay, so that's a formula. That's condition. We'll use it. So in fact, if you rewrite D by D, it will be exactly 5.77 for maximum torque condition. T max condition. So this is a relationship we are going to use it. Okay. So can you find out what would be the yeah, when you have D by D, right, 0.577, D we can find out straight away 57 millimeter. Maybe you can make it approximately 58 millimeter. Yeah, 58 millimeter is clearly given. Okay. So now we have to find out the clamping force first. We need to find out the clamping force first. Then only we can able to find out the number of thing. So now we got one aspect is the inner diameter of clutch is equal to 58 mm. This is fine. Okay. Yeah, clamping force. Capital P equal to this is the equation, right? You hope you remember. Just substitute by point. This should be suffix into 58 100 minus 58 or in millimeter. Okay, we are not going to change anything. Obviously. So what is the clamping force are you getting? Are you getting 1913.23 Newton? This is the value you should expect. Okay, this is your clamping force. Yeah. So now ultimately we have to find out the number of surfaces, the number of pairs for transmitting 75 Newton meter torque. So T equal to mu P Z, right, and D plus D by 4. This is based on uniform wear theory, and we know this is 75 Newton meter. 0.1 P is given 19.13.23, right. Z we have to find out, and this is careful. You need to have to be very careful here. Here you have to use a meter. All are in meter, right? So here you use meter. 100, right, into 10 power minus 3 plus 58 into 10 power minus 3 by 2, sorry, by 4. Can you tell me how many number of surface you are expecting here? So just substitute all the values here and find out what is the Z value. The Z value, okay. How much? Yeah, that is round actual. Yeah, 9.9. I just wanted to explain. So obviously number of surfaces cannot be as a decimals, it has to be whole number. So the total surfaces, right, number 10, right, the total pair surfaces. So in fact, if you want to understand number of disk, right, z plus 1, that is what we said. So it will be 11 disk you have. So how many rotor disks, how many stator or frictional disk, that is the questions. How many do you expect here? How many? 6 plus 5, that is it. Always rotor, right, they have to be outsider, then you will have things, okay. Yeah, that is the thing. I think this is for the multi-disk aspect. Now we'll go for the another problem. Question number 3 for cone clutch aspect. Okay. A cone clutch is used to connect an electric motor running at 1440 RPM with the machine which is stationary. The machine is equivalent to a rotor of 150 kg mass and radius of gyration as 250 millimeter. The machine has to be brought to the full speed of 1440 RPM from stationary condition in 40-second duration. The semicone angle is given 12.5 degree. The mean radius of the clutch is twice the face width. The coefficient of friction is 0.2. The normal intensity of pressure between the contact surfaces should not exceed 0.1 Newton per millimeter square. Assuming uniform wear criterion, calculate A, inner and outer diameters of cone clutch, find out the face width of the friction lining, C, the force required to engage the clutch, which is clamping force, and 4 or D, the amount of heat generated during the each engagement of the clutch. We have to find out. Okay. Yeah. So the in fact the data wise, if you look at there is a speed is given, cone angle is given, coefficient of friction is given, maximum allowable pressure is given, but no information about the inner and outer diameter of cone clutch, but there is a relationship is given, face width. The face width is given, I mean RM, it should be twice of the face width, that is the only thing is given. Okay. Yeah. So what is the way to we are going to solve this problem? Anything? Any idea would like to share? Yeah, you need to find out the torque. The torque is not given. Okay, torque is not given. So we need to know what would be the torque. Okay. So once you know the torque, then you can use the standard. Find out torque, then use the standard cone clutch torque equation. From there, find out the inner and outer diameter, then face width and the clamping force. So we are doing in the reverse manner. Right. The data is given, your speed, given data 1014 so much RPM. Yeah, that is correct. Mu is given 0.2. Okay, your mean radius is 2 times of face width. Then your allowable pressure is equal to 0.1 Newton per millimeter square. Alpha given 12.5 degree. This is clearly given. Okay. Then something they are talking about the mass 150 kg. Right. Then the radius of gyration K is how much is given? 250 mm. Okay, 250 mm or else 0.25 meter. And time is given, T is given 40 second. Yeah, that's a clearly. Right. What will be the initial speed? It's a stationary, right? It's a stationary. Initial speed is omega 1. Omega 1 equal to 0. Then final speed omega 2 equal to 2 pi n by 60. So, this is the where you have to substitute because you have to achieve 1440 rpm, right. That is what is clearly given, 1440 by 60. So, that should give me 150.8 radian per second, 150.8 radian per second. Okay. So, now I know omega 1 equals 0, I know corresponding omega 2. Do you know angular acceleration? Because these are rotating masses, these are rotating thing, right. So, you need to know that angular acceleration alpha angular acceleration nothing but omega 2 minus omega 1 by t, right. So, 150.8 by this is 0 anyway, right. That should be how much is second, 40 second. So, what is the angular acceleration? 3.77 so much radian per second square, alpha is given. Okay, that's we got it. Yeah. Can I move to the next slide? Is okay? Yeah. So, my torque T equal to I alpha. I is moment of inertia, which is nothing but m into k square. Yeah, m into k square. Then you have alpha. So, what is the m here given? 150 mass, right. K 0.25 whole square, then 3.77. Okay. So, can you tell me what could be the torque? 35.34. Excellent. Yeah, 35.34 so much Newton meter. So, we got straight away the torque from the things. Okay. So, now the condition is we need to find out what would be the dimensions, right, and also we need to find out the clamping force, all those information is there. So, you have to use the uniform wear theory, right, you have to use the uniform wear theory. Yeah. Before going to use the uniform wear theory, the relationship given, right. So, let me draw the things. I am just showing the only the half of the clutch aspect. Yeah. Right. So, this is your face width, assuming that this is the face width. Yes. So, this is would be my inner diameter, right, the cone thing. This will be d by 2, this will be d by 2, and this would be capital D by 2. That is the information, and this is your alpha is given, right. So, we know RMS is given as a 2 times face width is given, 2 times face width is given. That is one relationship is given. Okay. Can you find out what will be the B from in this diagram, right? What is the thing? I want to find out, maybe can you tell me what is the sin alpha here? What is sin alpha here? Can we say difference of these two, right? D by 2 by 2, right? Yeah, 2bx, correct. Yeah, capital D minus small d by 2b, that is a relationship. Already we know Rm equal to 2b, Rm is nothing but capital D small d, right, by 4 equal to 2b. So, now can you tell me what is that we are having, right. So, now we know that. Okay. So, now we know that. So, you can make it as a this is a and this is equation B using equations A and B, right. So, we would expect d by d 4 plus sin alpha and 4 minus sin alpha. Alpha is given 12.5, right, alpha is given 12.5. So, if you substitute, you will get the ratio 1.1144. Okay. So, fine. So, can you find out what is the diameter inner and outer? So, your D will be 117.29 millimeter. Okay. A small d equal to 159.09. Maybe we approximate 160, and this should be 178 also. It's okay. Yeah. So, what is the B actually? What will be the B? B would be 2B, right? Okay. So, this should be 178 plus 160 by 8. What is the value you are getting? What is the value? Are you getting 42 millimeter? The face width? Approximately 42 millimeter. That's the value, face width is given. Okay. Now, I had to find out what would be the clamping force. The clamping force sorry. Sin alpha, just I want to do mu. Substitute please, yeah, 4 into torque, already we know that. So, torque we got how much we got? 35.34 sin 12.5. Mu equal to 0.1, right? Yeah, mu equal to 0.2, sorry, 0.2, 178 plus, okay, 60 into 10 per minus 3, converting into meter. So, that gives me clamping force 455 Newton. Yeah, this should be the clamping force 455 Newton. So, ultimately what they are asking, how much heat generated, right? Heat generated similar to your brake. Similar to heat generated means, so initially 0 speed, then you make a contact, you will achieve the another speed, right. So, within that what is the power generation, that is the question. Okay. The heat generation, right, m into, sorry, theta into t, so t into theta, that is it, right. T already known to you, we have to find out the theta, right. So, you know omega 1 equal to 0, omega t equal to, already we know 150.8 radian per second. Yeah. So, we need to know the average, because the entire, during the entire operation we have to take the average velocity. Yes. So, that is 75 omega 1 plus omega 2 by 2, similar to brake aspect, that should give you 75.4 radian per second, right. Theta nothing but, what is the theta? Omega into t, yeah, 75.4 into 40. So, that gives you theta 3016 so much radians. So, if you multiply 35.34 into 3016, I should expect 106.59 so much kilojoule the heat generation. This must heat generated while clutch is engaged. So, even though the taken 40 seconds, right, but you can see the how much heat generated is generated during the clutch operation, I think. So, I will stop now. Tomorrow I will continue with the centrifugal clutch, then we will go for the dynamic analysis. Okay. Before going to dynamic analysis, I will cover about the theory aspect. Okay. Thank you.